I really don't know what exactly is the reason for this. Okay, so but I did some research and find out that okay, it may be depending upon the version of the OpenOCD. Okay, the newer version may be having some problem. There is really need to search for that version which works fine. Okay, so this is truly based on trial and error method, but I really don't know what exactly is the problem. Okay, so what I did was just close this. Okay, go to the OpenOCD release. Okay, actually we use the latest release. Okay, and which is giving now the problem. All right, so what I suggest to you is go and try the next version. Okay, so in this course for your demonstration, what I'm going to use is I'm going to use a version which is this one. Okay, just click next here. That is this one, 2017-012-41841. So this is because I have already used this and it works fine. I suggest you to try with this. Okay, and of course you can also try okay the newer versions. Okay, which came before this. Okay, because this is a version we used which is giving this error. Okay, and you are free to check this version. Okay, so you can do that. You can always do that experiment. Okay, but for this experiment okay, I'm going to use this one. All right, so now let's launch this exe. Yes, let's install this OpenOCD. Okay, so let me change the path here. My path would be this one, right? So I'll just copy this and I'll just paste here. Okay, install, finish. All right, so I just created this folder here. Okay, OpenOCD, which is this version. Okay, and now I'm going to bin, and I'm just going to copy this path. Okay, now I'm going to change my configuration here. What I have to do, I have to go to run, external tools, and click on external tools configuration. So this is the one we created where we gave this path. Okay, this version, right? So let's delete that. Okay, let's delete this also, and now copy this version path here. Okay, and paste here. Okay, and slash openocd.exe. so I'm just changing the version. Okay, that's it. And now let's go to scripts here. Okay, and select this, paste here. Great, so only these two changes, the rest all are same. Apply, close. Okay, great. So now let's try once again. Go to external tools here and click on and try to launch your OpenOCD. Okay, so it is throwing some error that LSUSB is open, failed, etc. Okay, so what you do is just disconnect your hardware. Okay, and here click terminate. Okay, so it is terminated. OpenOCD is terminated. Okay, and now again connect your hardware back to the PC and again try to open the OpenOCD, and now you can see that it is detected my ST-Link and it is opened successfully. Okay, and now let's try to flash and debug our code. So for that we have to launch our debug configuration, Blinky debug. Okay, so now again it is throwing error. Don't worry, we'll debug that. Okay, just click on details, and this time the error is different. Okay, so what it is showing is error in final launch. Okay, here you can see it is saying load failed. Okay, so that means the debugger, that is the GDB, tried to use OpenOCD in order to flash our code onto the flash of our microcontroller, and it said the load failed. Okay, and you can see here. Okay, error message is from debugger backend. Now close this. Okay, just click no. Okay, so that means there is a problem in loading our code. So why do you think this is happening? This is happening because you have not mentioned proper addresses of your flash as well as RAM in the linker script, that is mem.ld. Here you can see that flash is 0 and RAM is correct actually, that is RAM starts from this address, but the flash doesn't start from this address. Okay, we don't know from where it starts. You have to refer your reference manual of your microcontroller to know from where exactly the flash starts. Okay, so I just downloaded my reference manual for my microcontroller. Okay, so if you don't know how to download that, I would suggest you to type your microcontroller STM32, in my case F446RE. Okay, and just open the official documentation regarding that microcontroller, and here you can see the data sheet and various other documents. Okay, and here you will also find the reference manual. Okay, under the section reference manuals, and you have to download this file. Okay, so that's what I downloaded here. Okay, and let me open that. All right, so I just opened the reference manual. Okay, and here you have to go to the section embedded flash memory. Okay, and just click on introduction. Okay, and you have to search here in order to understand the flash sectors. Okay, so you can see the flash starts from this address. Okay, the sector 0 of the main flash memory starts from this address, and the sector size is 16 kilobytes. So there are 7 such sectors. Okay, so just copy this address, the base address. Okay, and come to your Eclipse project, go to mem.ld, and here you have to change that. Okay, just paste that. Okay, so the flash starts from here. So because the flash actually starts from here, so that means strictly speaking your code will be stored from this location onwards. Okay, in the memory map. Okay, and the RAM. Okay, so to understand RAM, from where RAM starts, again you have to check actually, but for most of the ST microcontrollers it starts from here. Okay, but it's better to check. So how to check? I would suggest you to okay, so how to check? So what you have to do is click here memory and bus architecture, click on memory organization. Okay, and click on embedded SRAM. Okay, and here you can see that it has 2 SRAMs, SRAM1 and SRAM2, so which starts from this address. Okay, so that is correct actually. Okay, actually you have to verify all these entries here, and you have to replace with a valid address by picking valid value from the reference manual. Okay, for example, it says that external RAM starts from this address. I don't know whether it is true or not, so you have to verify that. Okay, block 1, block 2, block 3 starts from these addresses which are not initialized properly. You might have to do that, but for our project it won't cause any problem. Okay, because we are not going to touch these memory locations. Okay, great. So now let's save this. Now just go to your project and right click and select clean project. So let's clean that first and then click on build. Okay, let's rebuild the project. Okay, so now the project has built successfully. So now let's launch our OpenOCD first. Okay, click on OpenOCD. So OpenOCD is launched successfully. You can see that ST-Link is detected, and now let's launch our debug configuration. Okay, so this is the application we want to launch. We want to flash and launch the debug, right? And you can see that there are no such errors. Okay, now click on yes here, because the Eclipse actually wants to change its perspective. Okay, let's click yes. And yes, we indeed flashed our code and the debug perspective is shown. Okay, so now you can see that the pointer is pointing to the main, okay, and the code is flashed but it is not running, okay. So you can see that the thread here is suspended. That means the breakpoint is hit here, okay. So now let's see whether our code is running or not. We'll just click first resume here. This is kind of a run button in your keel, okay. And when I click that, you can see that yes, our application is indeed running, okay, on the hardware, okay. It is printing some data, which is some, it prints this string for every 1 second, okay. So that's what implemented in the main.c. Fine. If I want to stop the execution, I can just click on suspend, and here you can see it is running now, and if I click stop, the main thread is suspended, okay. And this is a call stack, so that means before halting it executed last function, that is time underscore sleep. That's fine. So that is internal code, that let's not worry about that, okay. So you can write whatever you want, okay. And now let me teach you how to put breakpoint. Let's say this is trapped in a while loop, right? So let me keep one breakpoint here. I think you can see this blue strip here, right? Sky blue strip. There, go and double click. So that actually inserts one breakpoint. Now let's click on resume. Okay, and you can see that the execution halted at this position. Okay, great. So like that, so all these things you can do, and this is your output. Okay, and okay, so these are different panels in which you can observe your variables, its state, its data, etc. Okay, great. So now we are in the Eclipse debug perspective. Remember, we are in the debug perspective, and if you want to switch to your C and C++ editing perspective, you can click here. Okay, C and C++ tab. So it will take you to the editing perspective. Okay, and if you want to again go back to debug perspective, click here. Okay, so it will take you to the debug perspective. Now the code is halted at this position. Okay, so now you can remove this breakpoint. Again, double click here and just hit run or resume. Okay, and you will see that it will continue executing on the board. Okay, and now if you want to terminate your debugging perspective, so what you have to do is, okay, so you can just kill your debug by pressing here terminate. So once you click that, your debug is terminated. Okay, so the debug is terminated, but your OpenOCD is still running. So if you want to start your debug again, what you have to do is you have to click here. Okay, and you can select relaunch. Okay, you can see that the debug is again started. Okay, and again if you want to kill, just click on terminate. Okay, and if you want to terminate your OpenOCD, then click here to terminate OpenOCD. Now both the OpenOCD and GDB debugging is terminated. Okay, so now you can go to your C and C++ perspective by clicking here, and again you can edit code, rebuild, and again launch your debug. Okay, remember that before launching your debug, you have to first start the OpenOCD and then start your debug. Okay, great. So you just successfully executed your first application on the hardware. Okay.